Okay, so you can see, I think like the general flow, right, is like first we want to build our vector database, and then we want to be able to query that vector database, right? Um, so you can get a sense of like the overview if you look at this builddb.py function, right, which is here. So what you can see is like, we read in these reviews. Um, it's, the reviews is a bunch of CSV files. I think it's like Amazon reviews. So we read the CSV. We then combine the data. I think this function is supposed to, yeah, it has like the reviews where we both have like, oh no, sorry, it's restaurant reviews. So we both have the restaurant name and the review. So we just want to like combine this information. From there, we want to convert the text here to vectors, right? So as we know, right, like these vectors are going to basically like represent our strings. And by converting these strings into vectors, that's the way that then when someone queries our database, we'll also turn that query into a vector and then, perform like a nearest neighbors, essentially assess what's most similar, which entry in our database is most similar to the query vector. So we combine the data, we convert to vectors, and then this building embeddings df, this is just a data frame that both has the vector along with the original text. And then the issue with it, the reason why with this build in batches is essentially in order to get the vector that corresponds to the text, we need to hit the API, and we can only hit, the API, right? Like so many times at a time. We can only feed so much text at a time to our API. So the idea is like, hey, let's instead of feeding our entire data frame, let's just feed a segment of a time of it to the API. And you can see that, I said there were kind of two issues. One is we can only feed, so much data at a time to OpenAI. The second thing is we have to make sure that we have to be passing through strings. So you can't pass through any NaN values. And then the next step is like, so this is the whole process for building the database. And then the next step will be querying the database. All right. So we can get to that later. But for now, let's just maybe work through this. So the first function is this, and we can kind of comment this out. So it's like read the CSV. Let me see this. Oh, there's nothing on the console. That's nice. Okay, so read the CSV, then combine the data. We know that this combined data should look something like this, right? So, and I do have tests. Do I have tests? Wow. It's just in a weird spot. Oh, here's my tests. Cool. So so this is pretty useful for then, so you can see the what's supposed to happen. So the combined data, I guess, takes this data frame, and then based on, you can imagine restaurant is one column, reviewer is another, and then finally we have the review, right? And we want to combine this, right? So this converts it to a data frame. We call combined data, and that should take this text, this column, and then this column, right, and combine it. So that's pretty good. We should then perhaps run the test. Yeah, so let's see if I can do that. PyTest tests, and we can do test embeddings builder, db builder, test embeddings builder, and then let's just put a breakpoint here. Okay, and run it. Right, so we hit our breakpoint, right? This is our typical thing, right? When we run the test, it's going to go through, right, run this code first, declare this data, create our data frame, then pass through the data frame into here. So now we're in this function right here, right? And the data frame is that data frame from the test. So if we look at df, we can see that, this is the data. And then what we want to return is this kind of style. So the way that we can do that is, first we can perhaps select the restaurant, right? And so you can see this returns two, a series, so two entries. And what you could do is do something like this, restaurant name plus that. So you see what that does? It's like, it's kind of weird. It's not very like Pythonic, but in pandas, something like this can work where, right, this, I forget I was trying to think of the name for this, where basically it applies this plus function to every entry in the data frame, right? So we would do something like that, right? It would be the string restaurant. Let me just make sure I have it right. So we want to get this format, restaurant name, right? Plus df square bracket restaurant. And then what comes next, right? It's going to be the review. Restaurant name, the name, review, colon, space. Plus review, colon, space, plus, this is probably going to be like df review. Before we rerun the test, let's just take a look, see if this would work. So basically all we're doing is just selecting a couple columns and then adding strings, right? And this should combine it. Oops, and we're a little off, right? We want to put a space here. And then we just make sure again that this looks right. So it's restaurant name colon space. Let's do that. Okay, let's try it again. Okay, restaurant name colon space, and now we need another space here. Let's try this again. Okay, this is looking better. Let's just compare it to the test. This looks pretty good. I think it's time to run the test. Exit restaurant name beyond flavors, review, colon space. Yeah. So let's just make sure I save my file. I'm gonna run it, see if anything works. And for failed, let's take a look. None type has no attribute to list. Why is this? Right? We should all know. So if I have combined data, I'm assigning this to a series, and then I'm getting a none type error. That probably means what, right? That the combined data function's not returning a value. And so then we're trying to call to list on a none type. So let's return this. Okay, and now we got one passing. So just to review, what I did was if you can select the columns and then adding a string or performing an operation that will apply to every row in that column, right? And this is returning a single series. So that's fine. The next thing, text to vectors, takes in a list of strings and returns a corresponding NumPy array as the embedded vector for each string. So what we'll need for this is the OpenAI, right, like API. So you can see I had to create a new API key, so I can send this out to you later. But this just builds the client. This just builds the connection to OpenAI. And we're going to need this, right? We're going to need this client. So called build client, right? And that's returning this OpenAI client. And then from there, we can kind of like use the code to do this. I can put a breakpoint here. So if I run the test now, this test embeddings builder, just think about what's going to happen. This will now go, so we pass this one, we'll go to test text to vectors. That will pass through some text, right, the text that we generated, into this function. And then we'll go here, we'll call our client, we'll also have our text inputs. I'm going to do one more thing just because it will make it a little easier. I know that we're going to need to specify the model, and for that one, it's text embedding 3 small. Okay, so this is the OpenAI model that we'll need to specify. And now we can run this and hit our breakpoint. Okay, and now we have our client. Okay, and you can just then, like, I think this was in the reading, you can do client.embeddings, and then there's like the create. So this is going to be how we create the embeddings, right? And what we can pass through is the list of inputs. So the inputs we have are the text inputs, right? So this is a list of strings. This looks okay. And then basically we're gonna, so client.embeddings.create will pass through the list of strings. So that's my text inputs. And then I think the model is the other thing. So model equals that model that we declared here. Okay, and then that should, I think, return to us if we look at the result. Just call this res. Oopsies. I think I need to declare this as inputs. So I'm forgetting a keyword argument here. I think that needs to be inputs. Okay, what is it called? It is called input. Sorry. This has to be input. All right, so you can see that took a second too, right? Why? Because it's taking these vector or these strings and hitting the API to find the corresponding vector. So we get this res, that's a mess, but the point of this, I think you call res.data, and then if you look at it, looks like a mess, but if you can kind of look at it. If you look at the length of this, right, we should get back, it should have a length of 2. One for each of the text strings that we pass through. We get back a corresponding data. And then if you look at any one of these, right, this is like a NumPy array. And that's what represents, oh, it's an embedding. So then if we do, I think we can call, NumPy, like you can call np.array of this embedding. So we can basically turn this into a NumPy array, I think. Or we can call .embedding. And now that, I believe, is, if we look at it, is the NumPy array. Oh, it's a class list. Okay. So we'll turn this into a NumPy array. So basically, just because I'm moving a little fast, let me just go back. So the way that we started was, and I'm just like exploring this interface. So you can see I type in res, and I'm just looking, what does it say? It says create embedding response. That's the name of the object of, just like some sort of OpenAI object, like instance that's getting returned. And it has an attribute called data that we can see, right? If you're not sure about this, right, you can just do res, probably .dunderdict.keys, right? And it shows you the data, and then from here we can say, okay, here's the data. And we saw that I think there's one for each input that we pass through. And then the same thing, we can take a look at what this is. So this is, each vector is called an embedding object. And then to get to it, we just do .embedding, right? And now it's like, well, what is this? So it looks like a list, and we know that it is a list by typing type around here. And the only issue is that instead of, having a list, we want each of these to be a NumPy array. So we can call this like our vector, right? And then let's import NumPy as np and do np.array and pass through the vector. And this would be like my np array, right? And then if you look at this np array, this looks right. It looks shorter, but you can see there's a lot of dot in here. You can take a look at it by calling np.shape, right? And that returns to you the length of the vector. Okay, so our text, each one of our text strings was, we have an embedding for each one, and then we want to convert each embedding into a NumPy array. So to do that, now that kind of we have a sense of the data, and we called this with this line of code. Right, so we called our API. So this is our client. We got the text inputs. We passed through those text inputs to the API and it specified the model to get back like a response embeddings. Right? And then we did something like response.data, and then that returns a list of embeddings. It's response embeddings.data, and these are kind of like our embeddings, right? And then we can just iterate through them. So like for embedding, in embeddings, right? And if you're just unsure about it, just look at it. And that returns to us an embedding object, and then we can do embedding.embedding. Right? And that returns to us a list. Right? That returns to us a list. And then we turn each one of these lists into a NumPy array. Okay? And it's saying probably undefined because I need to, I know I am importing NumPy up top. And we want to return this, I think. So once we hit the API, I'm basically just exploring it to see what we get back. We get back this data thing, which returns a list of embedding objects. We go through each embedding object, call .embedding on it to get the list, and then turn that list into a NumPy array, and then return this. Okay? So I think, and then we can confirm that that looks pretty good. So the length of the vectors is 2, and here I select the first value from the vector. And it should be right. Let me just, yeah. Right, and I have 2 passing now. Okay, so that's pretty good. So this was probably like one of the harder ones. Well, not as hard as this one. But the next thing is then build the embeddings DF. So I don't think this is that bad. You can see there's 2 columns, right? Text and embeddings. And then we have these 2 pieces of data, I think, right? Because we get the text inputs and we can get the vectors from this text to vectors functions, right? So if we do this, we can get the vectors, right? They pass through the text inputs. We get back the vectors. And now we can do something like pd.dataframe and get, I guess, I mean, there's different ways. I mean, the easiest way is we can first do the text inputs, set the columns equal to text. That was the name of it. Yeah, text. That'll be my df, and then we'll get the vectors. So we'll do df.assign, and we'll say vectors. Is it vectors or vector? Embedding. Say the embedding column equals vectors. This is my embedding df, and then we'll return it. Okay. Right, so it's like start with these text inputs. For this, we need both the text inputs and the vectors. We get the vectors by using the earlier function. We start creating the data frame. We add a new column, and then we return it. Let's see. Oopsies. So what did I do wrong? Test text. Oh, this is off. That's not fun. The other one's good, though. It's very close. Maybe I'm using a different model. I guess it's slightly different. Or it could be that the model was updated. So my sense is this is just a brittle test. 0.04737, 0.04781. One time I had a value wrong, but when I reran it, the test passed. If you run it again, it could change. So yeah, it seems like this is a brittle test, meaning the problem isn't with our code. The problem is this test. This is not the way we should be testing that we did the right thing. So I'll return that. I'll remove. Just sorry if this hung you all up. We can just comment this out. So this is fine. You can delete this, and let's just run it again. Cool. So we got 3 now. Okay. So what did we do so far? Right. If you think about these functions, let's go here. Right. We read in our file, like our data frame, the list of reviews. We then combined our data to get that, right, like restaurant name thing plus the review. Then the next thing I guess we're leading up to is to build in batches, right? Basically our database, meaning a data frame that has the original text, right? The text and the corresponding embedding, right? And then what we'll do is when an input vector comes in, we'll calculate the distances between the query, like if they say, what is the best restaurant for, a burger, right? Then this will convert to an embedding, meaning to like one of those long vectors, and we'll calculate the distance between this input vector and all the other vectors, and then we'll sort to find the 3 closest vectors, and then from there we'll take the results and send them to our LLM. So this building batches, I think what this does is we basically so the combined series, what's that? That's this basically our original data with, right, it's this thing right here. So you can see that built-in batches, reads from the reviews. We're just getting, I guess, 300 of them to be easy. Calls combined data, right, which gives us back that series of the restaurant name and text. And then we call built-in batches from there, okay? And you can see batch size is 30. So we only want to do 30 at a time. So the hard part of this, I think, is, and this is like a useful thing to know, is basically what we want to do. If you think like you have a data frame or you have a series, that's our combined series. I think what we want to do is just select a portion of it at a time, So you remember you can do like iloc to select the data. And then we kind of need like the starting point, starting index, to like the end index. And that's kind of what we need to like iterate through. So to iterate through indexes, we probably can do like for I in range, right? And go through from where? Starting at 0, down to the end, right? I think down to the end. And then I would say the third argument in range is the step size. Okay, so we want to go through in groups of 30. So the end will be the length of this combined series, right? And then the step size will be the batch size. I think that would do it. And let's just like print this out, right? And now what do we want? Sorry, I'll show this one more time. Like what do we want these values to be, the starting index and the ending index? Well, the starting index, right, should like start with 0 the first time and then be like 30 the second time. This is the starting index. And then the ending index should be like 30, right? And then here it should be 60, I think. So this thing is always, so if we start at 0, that's just the starting index. Then the ending index will be the starting index plus 30, right? Or plus, I should say plus the batch size. That makes sense. So we can kind of, let's call this my, my slice or my batch, I don't know, my batch. And then we can do batches, right? And then we can just append in each batch. Batches.append batch. We'll just take a look at it. And let's put a breakpoint here. Starting index is not defined. Cool. So the starting index should be for starting index, right? Because that's what we're iterating through. That's what this is, right? So this will start at 0, and then then go up until that length, but have a batch size of 30. So it should be 0, then 30, etc. So let's do this again. Okay. So let's take a look at batches. That doesn't look right. Seems like I'm doing something wrong. Let's take a look at the first one. Okay, so this goes from 0 to 29. So that's good. And then the second one, maybe I'm doing this wrong. Do I have this step wrong? Let me take a look at my code. 0 length, batch size. Yeah, that looks pretty good. Okay, let's take a look at the second one. So this is the first batch, right? It's going from 0 to 29. Let's take a look at batches 1. Oh, this is right. It's going from 30 to 59, right? And then batches 2 is going from, oh yeah, here's batches 2, going from 60 to 89. So this is good, right? It's 30 in each batch, it looks like, until the end. And then basically what we'll want to do probably is take each one of these batches, right, and then call this building embed, no, not that, text to vector. Yeah, I guess this. This will return to us the corresponding data frame by calling text to vectors, which hits our OpenAI client to get the vectors, and then, creates this data frame that has both the text and the vectors. Okay. And instead of passing through the text inputs, well, let me just make sure. Text inputs is supposed to be, I think, a list of strings. Let's take a look at the test to see what it takes. Text to vectors, text inputs is a list of strings, right? So we just want to make sure we keep the format right. So let's just take a look. So what we get in here is this, the input to the function is this combined series, okay? And then I think what we want to do is just call like toList on it, like you can do that. And now we have a list of strings, right? And this can be my text inputs, basically. Or we can just do batch dot toList. This will be my text inputs, right? And then I pass my text inputs, my list of strings, to here, and then build embeddings df will take those text inputs, convert it to a list of vectors, and then return to me a data frame. And then basically this is my, embedding df that I want to add, I want to append this result, and then that's basically what I want to then ultimately combine. So I'll call this embeddings dfs. Okay, let's see if this works, and then from there we can I can just review it again how I did this. We may run into a problem, like if we have an NA value. Right, it's taking a while. That's a good thing. It means it's hitting, it's feeding like 300 records to our API in 10 batches. So that's okay. Okay, we finally hit our breakpoint. We didn't see any errors. That's good. Let's take a look at my embeddings df. Embedding dfs, I called it. Right, and you can see, let's take a look at each one of them. Like if you look at the first one, this first one, if you look at the type, this is a data frame, right? And the second one is also a data frame. So what I have here is a list of data frames, right? That eventually I'm going to want to combine together into one data frame. But it looks like this is working, because if we look at just one of them, right, you can see we have the text, right? The restaurant, the text, and then the corresponding embedding to go along with it. I want to make sure that if I look at the embedding. Let's just do iloc 0. Like look at the first entry here. I just want to make sure that if I look at embedding, that it's a NumPy array. I wanted to make sure it's a NumPy array and not like just a regular list. So what we did, right? We have our end result right now is we have a list of data frames, embedding df, something like that. A list of data frames where each data frame has both the text and the embedding. The way we got that was by using the range function to go from 0 to the length of the series in a step size of our batch size. And then we said, let's slice for that entire set of 300 entries. Let's just slice 0 to 0 plus the batch size. So 0 to 30, and then the second time 30 to 30 plus the batch size, right? So 30 to 59 or whatever it was. Then we needed to convert that series to a list, right? And this is just our reviews, like the pure text. And then we called build embeddings df, which takes the list of strings, and for each one returns a data frame that has both the original text and the corresponding embedding, and then we append that data frame to a list, right, to get the whole set of them, and then we just need to turn this into one giant data frame. And the way we can do that is use the concat function. So this is embedding dfs. This is a list, right? A list of data frames, as you can see, right? This first one is a data frame. And then what we need to do is do pd.concat. And concat means, right, push things together. And that will, combine basically this list of data frames into one data frame. And we should specify that axis equals 0. So this means that we're stacking these. 0 means vertically, and then 1 is columns, right? 0 is for rows and 1 is for columns. So this means combine these like vertically as opposed to combine them by just adding in, columns on columns on columns, right? So this should give me my combined df. And now if I look at the combined df.shape, right, you can see we're back to 300 rows. Okay, and then we can just return this. All right. This is hard. I think this is probably the hardest function. I've done it before, and I also have my notes right next to me. So if it's hard if this took a while or you're not done this yet, that's fine. Don't worry about it, but use it as an opportunity to practice both pandas and some Python. Let's see if this worked. We'll just run this. Okay, cool. So those passed. So what's next is I'll let you all finish the rest of it, which is then after we build the database, right? Then we'll store it in a Parquet file. It needs to be stored in a Parquet file, by the way, because a benefit of Parquet file is it maintains the data type. Meaning, remember this stuff's a NumPy array. If you store it as a CSV, it's not gonna, when you read it back in, it's gonna read that back in as a list of as one, not a list even, but a string with square brackets inside of it. Whereas storing and then reading as a Parquet file will maintain the data type, which is really nice. So this will serve as our database. So that's kind of the first thing. And then the next thing, I guess, is the LLM, where you can see I don't know, here, the LLM runner, I suppose, where we ask a question, and then we call this question and answer function. And what this does, I suppose, is somehow it takes in the question, and then it's going to probably convert the question to an embedding, right? And probably we could even maybe use that same embedding function, that we were just working with. And then what we want to do is calculate the cosine similarity between the embedding and the data in our database. Okay? Right? Because we have the embedding vector and then we have all of the vectors for the database. We find those that have the shortest distance just by using some pandas, sort it, and then we'll take those results. I'm guessing those top 3 text results, combine them, and then just like combine them into one string, and then basically feed that to our ChatGPT, right? And now this way, when we say like what restaurant has the best burgers, it will have the correct context, right, to answer that question. Sound good? Anything you want me to go over again? And like I said, like it's okay if you spend more time, like if you didn't get through the DB Builder part, and you want to spend another whatever hour or something on that. That's okay. All right. Okay, so I'll send out thing that, and I was at this conference on LLMs, and like vector databases and things like that. And one thing that one of the speakers said was like, if you feel confused by this material, or like you're totally new or in over your head, like just remember, even like the experts have only been doing this for 6 months. Like everyone has only been doing this. Everyone speaking at the conference has only been doing it for 6 months. So like nobody, if someone seems super advanced, they're like 3 weeks ahead of you. Okay, they're really not any further than that. And like even when I was at the conference, like the people that I was talking to were like, "Oh, you guys are doing the really cool stuff." It's like everyone kind of feels like just on shaky ground, I think, because it is so new and people are figuring things out like as they go. Let's get into some of it. Okay, and then I wanted to show you, maybe just give you an overview as to what Llama Index is. The actual documentation is pretty good. Llama Index has a mix of I say some of the documentation that you can find is really good, but then sometimes it's not as organized as you would want. But there are some really good tutorials on it. Let me click on this. Llama Index documentation. Here we go. All right, so here's the documentation, and then what we're looking for is high-level concepts. Okay, so look, this we kind of know, right? RAG, right off the bat. Also, just notice the picture that they have for us is here's the input data that you can be getting, right? That you can imagine, right? This is an OLTP database. Maybe there's a PDF. Maybe this is API, right? Feels kind of like what we ETL or what we normally do with a data pipeline. So pull in the data, load it. They use the word index, right? But you can think of this as a database, a vector database, which is stored. Then what happens? The user comes in and asks a question. They put in their query. The query gets translated to a vector, goes to the vector database, retrieves the relevant vectors and chunks of data, right? The relevant text, feeds that to the LLM with the prompt, the query, right, and the relevant data, right? So hey, please answer this question in 2 to 3 sentences. What is the best restaurant to get a burger? And here's now 3 of the relevant chunks that give some information about good burgers, right? Feeds to the LLM, and then the LLM gives you back the response, right? Starting to feel more familiar. So what Llama Index does is this is a library that basically they're saying everybody's doing the same kind of stuff. What may change is for instance, the kind of database that you store this in, that may change. We're going to use like some like out of the box in-memory database to start off with, but then you can move to like Pinecone, or you could use, move to like Neo4j, right? Like different kinds of vector databases. But, what if we have like a wrapper around each of them, like a Python, that either way, we kind of create this common functionality for working with a vector database. This may feel like SQL Alchemy. We haven't officially touched on that yet, but like, right, the sense that like SQL Alchemy can play with different kinds of databases, or the sense that like DBT can work with different kinds of databases. Right, this is a library that allows us to do like common functions, but then interact with different kinds of databases. Loading data, right? We're going to have to read PDF documents or like read HTML documents and parse it somehow, right? Like, so they give us like different like loaders for how to eat like different like just functions for quickly pulling this data, and it kind of says it, whether it's text files, PDFs, websites, databases, right? And then like formatting it, giving us some help with formatting that data so that it's ready for an LLM. Indexing the data. This means creating a data structure that allows for querying the data. So like when you store the data in this database, right, like currently what we're doing in order to find the relevant the relevant vectors is going one by one, right, and looking at the distance from the query vector for each stored record in our vector database. But you could imagine that maybe we do a query vector, that the person says, show me good burgers, and then we first identify burgers, and that in our database we already indexed it so that when we see anything about burgers, we kind of like tag it, So now instead of looking at all the data, maybe we just look at those rows that correspond to a keyword, right? And that's like indexing it, or at least one strategy we can choose for indexing it. So it can like help us with that. Storing the data, right, we talked about, it can like, help us with, storing data in a vector database, like have a wrapper around it, querying the data, right? The fact that when someone puts in text, we first need to translate that to an embedding, right? And then we need to, go through and find this data. How do we want to find it? We use one technique of like cosine similarity, but there are other similarity scores that you can use, right? So it gives us options for that. Then evaluation, right? Seeing like how well this pipeline is performing. So you can see like I think this already is just like a useful way of thinking about stuff. So what are we starting with? The loading stage, right? Nodes and documents. All right, so that's what we're starting with. I'm not even sure how far, like, we'll see how far we get through this. But even if we just get to like this stage, honestly, and maybe a little bit of this, that's quite good. That would be like, I think you can make a lot of progress in your internships and with projects with just a few of these concepts. All right, so let's start talking about that. What we'll do is we're going to start working with an entire PDF. And as we mentioned, we're not going to want to, we don't want to just store the entire PDF as one row in the database. So how are we going to break it up? Well, the most atomic, like the smallest unit that we can break up our text data into is our tokens, okay? And just to show you, I'm just using like, this is like a kind of old school NLP library, right? Natural language processing library, meaning like before LLMs, it has nothing to do with even deep learning. But still, even in that level, you still tokenize the text first. And when people say tokenize it, all they mean is basically you can see this text, not only is it each word is getting a separate token, but each punctuation piece of punctuation is getting a separate token. There are other strategies, like for instance, in certain tokenizations, maybe you just change this word to like the root word. So sleepwalking is the same thing as sleepwalk, right? In that way, you're like eliminating the differences between it. You may remove things called like stop words, right? Meaning like the, is, like very common words add low value when you're trying to, right? When you're trying to figure out the meaning behind it. So you just like kind of remove some of this stuff, and that can produce like a set of tokens. Okay, we're actually not going to be working with like tokenizing. All the libraries do that for us, but it will come up, like, just so you kind of understand this term. Generally, you can think of like there are 4 tokens for every 3 words, right? Like a token is like three-fourths of a word, essentially. So like slightly more tokens than you have words. The next thing is like chunks, right? This is something you'll start to think about. Okay, so like if you load in an entire PDF, how do you want to break that up, right? Like what are the rows in your database essentially to search through? And that's a chunk. Now there are different ways of doing that, and we can like get through, how that works. But for now, you can start to think of like with a PDF, maybe like each chunk would be a separate paragraph. Why would something like that work, make sense? Well, like in chunking, one thing you might consider is, we wanted to like encapsulate a concept, right? If we're going to turn our chunk into a paragraph, right? And then we're going to, use that, basically want to, retrieve that paragraph, feed it to the LLM, right? Then like the fact that a paragraph like holds consistent information, right? Topic sentence, conclusion sentence, right? Like that can be a pretty good sized chunk. Other things to consider is like LLMs, right, can, as kind of what I think Miles brought up about a context window, right, they're able to understand a certain amount of information at a time. So if you feed it chunks that are too large, it's just not going to understand or comprehend all that information and know exactly, what it should be focused on. And then like you can see this, like the kinds of questions the user asks. Typically longer questions mean, it was going to take more information to properly respond to them. Right, so whereas smaller questions probably can be, figured out with, the right snippet of information, right? We can just like answer it in a sentence. Whereas if it's a more complex question, probably it has a more complex answer, meaning we need to put together like more cohesive information, longer cohesive information that the LLM can then interpret. Okay, so, we can kind of get into that, but for right now, you can see what I did is I just like took some text and then split it by period, and therefore, I'm just literally creating a chunk based on each sentence, and maybe each one of those chunks can be a different row in the database. All right, so just to, we'll get into like some pure code in a second, but just to quickly cover it, Llama Index, they have these 2 different objects that you can think of. One is the document, right? Like the PDF document. You can see that I'm just literally feeding it the document text, meaning all the the entire string, all the text from a document. Like, right, if it's 100 pages, combine all those 100 pages into one string, feed it into the document, right? And then what we're doing is this line right here will return what's called nodes. What are nodes? Nodes are our chunks. Okay, so if we're saying here's a document and we're splitting it up essentially into a paragraph, each node would be a separate paragraph there. What does this thing do, this sentence splitter? It's saying, hey, try not to split something up mid-sentence, and the chunk size, right, this gets into our tokens. The chunk size is 1,024 tokens, right? But around that many, like 1,024 tokens, but don't split something up mid-sentence, right? Because then it's not going to, when it retrieves it, the LLM's not going to understand that mid-sentence. It's not going to help, right? So that's what's happening here. So there's basically like these 2 different objects right now that we're working with, a document and nodes, right? And document is like the overall, document, and then the nodes are the different chunks from that document. All right, so now we can start to get into it. Let me remove this. So the first thing we do is we use this FITS library. There are different libraries for like reading PDFs. If you think like PDFs can actually be kind of complicated to read, because sometimes it's not easy. If you can't like highlight over the text, it makes it harder for like a Python library to read it. Some of them are good at still like basically taking the image and figuring out the text in there. You might have heard of like OCRing, things like that. This FITS library actually comes from, or this FITS module comes from PyMu PDF, which is like very seems like very popular library and like not anything like super fancy to be reading our data with. Okay, so the first thing we can do is just like have a doc string, create an initial string, and then we can basically say like this is my document, right? You can kind of see this. So we're just reading the document from this PDF. This PDF is located here, right? And then we'll just say, okay, I don't really even need this line, page in enumerate. So we're just iterating through each of the pages in the document. So you can imagine this creates some sort of, fits object that we can then enumerate through each page, and then we can call page.getText, right? And this will spit out the text from each page on the PDF, and then we can just do like doc text. Let's call this by page text, and then we'll do doc text, right, plus or equal the page text. All right. So now all we did at this point was we just like took out the text from the entire PDF document, and then from there what we can do is say documents equals, right, this document object, and then pass through, I believe it is the text, is my doc text. All right, so I'm just feeding, and this should be a list, right? And this is like our first llama index object. Let's put a breakpoint. Yeah, let's just run this for now. Right, so we should be, reading this, then going through each of the pages, pulling out the text from it, appending it to the string. So now this would be one long string, and then we feed it into this document. So let's just take a look. If we look at doc text dot split on each word, and then look at the length of it, right? 20,000 words. Okay, that sounds about right. And now, right here, we have this list of documents. And you can see, let's just look at the first one. Here's my document. And a good thing to do, right, is dot keys. You see, okay, we have in this document, right, it seems like it has an ID, it has an embedding, it has, metadata, relationships. What would relationships be? Like maybe these are like annual reports. And so we have all the annual reports organized, and you can imagine like there's a before annual report and an after annual report, right? If this is the 2021 annual report, there's one that comes earlier and one that comes later, right? So you can like start to see it captures this various information about it. And then the next thing we can do is actually parse this thing, meaning chunk, or I should say chunk it. So the way that we can do that is we'll declare our sentence splitter. There it is. And say the chunk size equals 1024. And now we want to do parser dot get nodes from documents. Why isn't it complaining? Am I forgetting something? No, it's good. Okay, and I think that's good. Oh, and I need to pass through the list of documents. Right, so what I'm doing here is I'm creating a parser. This is something that like we have to tell it some rules for how to break our document into chunks. What we're saying is basically don't break it up mid-sentence and keep the size of it around 1,024 tokens, right? Which we're guessing is around a paragraph. And now this is going to call this function get nodes from documents, which then is going to return a list of nodes. And if you understand, once we get to nodes, you kind of understand that, then you're in very good shape. So what do we have? We have a document, or we have a list of documents, right? And we just have one of them. And then we have nodes. Now let's take a look at our nodes. Let's take a look at our first one. And you can see, so now you can start to see this, right? Here this node gets its own ID. The embedding is none right now, meaning we have not, hit the OpenAI to get the corresponding vector of this. All we have is, we do have some text. So here you can see, here's the text attribute, right? And then notice this one also has these relationships, right? And what's the relationship? There's a previous node, I believe, Yeah, you can see this here. Node relationship next, meaning not only does this thing know about its own node, but knows about what comes next. Why would something like that be useful to OpenAI or to an LLM? Well, think about it. Like, not only is the text valuable in figuring out some information about it, but also like the text in the next paragraph might be useful too, right? If we're talking about burgers in this one paragraph, and then the next paragraph talks about like a specific like McDonald's, now we can put two and two together to figure out, okay, if we ask a question about McDonald's burgers, chances are this node is relevant, even though it just talks about burgers, if the next one talks about McDonald's, right? So like that's kind of the idea. Is this is a little bit better than what we can do because it captures this like metadata information. All right. Right now we're not using it, but you can see that all this thing does is now if I look at text, the other some nice things that you can look at. Right, text is literally just a string. Let's look at dict.keys again. Right, the start character index, the end character index, something like that's interesting because now, we can maybe if we figure out what nodes are useful to a question or are relevant to a question, we can then figure out exactly where that string begins, where that paragraph begins in our document. Like, which of the paragraph start, which is the paragraph end in that entire document to pull that out, right? So like this is like fairly useful. The next thing, okay. So at this point, we did the nodes. Remember that we did not have any embeddings yet. The next thing to do is basically to call this, there's this node.getContent function. We can show you that. First node.getContent. All this does for us by default is just return the text, right? If this is a paragraph, right, you can see it's like table of contents, and then going into the paragraph. All this is doing for us right now is just returning to us the text. But this get content could also return like metadata about the node. For instance, it could return maybe like a summary of the previous paragraph, a summary of the successive one, and then instead of just feeding this to the LLM to be embedded, we can also feed it some metadata to the LLM so that has even more information, right? Maybe we can feed it the document title as well as the text of the paragraph, right, to give the LLM more information when producing the embedding. So basically what we can do is now go through each node, for a node in nodes. What we do, we'll get the content, which means for right now just get the text, and basically we can call this the content. And then what we can do is we need an embedding model. So this is OpenAI embedding. We have to pass through our API key. Actually, because this is set in my environmental variable, I don't think I need this. Let's not pass it through for now. I'll call this my embed model. Okay, and then we'll just do embed model dot get text embedding, and then pass through the content. Okay, so what do you think this returns? Right, this returns that actual vector, and then finally I can store that on the node. Node.embedding equals the embedding. All right, let's just take a look at this. I'll just put a breakpoint here, and we'll continue. Okay, so we're right here. If you look at the nodes, what we did was we read in a document. Then if we did this parser.getNodes from documents, basically this chunked it right into different paragraphs. If you look at the, why did I do that? If you look at the node at this point and you node.embedding, right, this returns none. Okay? So the next step that we do, all we have instead is just the text. Get content. Right, we just have the text, but we don't have any embedding. Then we'll hit continue and hope. All right, this is taking a while. That's a good thing, right? And because what this is doing is getting the content from each node, getting the text embedding that corresponds to that content, and then assigning that embedding, this vector, on the node. Cool. So now if I do node, here's my nodes, square bracket 0, dot embedding, now we have our vector, okay? And as we know, this vector represents a single paragraph or a single chunk of our data. What's the next thing that we can do is basically, now that we've embedded everything, all of our nodes, the next thing is to actually store this in a vector database. So we do this vector store index and store the nodes. So these nodes look good. It's time to basically store them in a database. And then you can call index.asQueryEngine. And then you can give it, I don't really think I need to do this, but I'll do response mode equals tree summarize. This is just, saying, hey, like summarize the text. I need to change this to be response mode. All right, and that will be my query engine. So what's going on here? This is going to actually store our nodes, and this will happen in memory. Okay, but this will be our vector database. And then we can use that same object to then call asQueryEngine. At that point, this will return to us a new object called like a query engine. We can take a look at it. And then we can ask that query, we can submit a query. So this is, I forget the content. Oh, we can just ask it, what is this report about? Probably should ask it something more interesting than that. I said, what is creative destruction? Okay, so that's pretty good. Let's run this. Right, it's taking a little while because it uses the API. This vector store index also uses the API, also uses the OpenAI API. So you'll need, again, the way that we're feeding it is we're declaring an environmental variable called OpenAI API key and setting that there. And basically, when you construct this will look in your environment. It'll say like OS environment to retrieve this, right? And and if it doesn't have it, it will throw an error. All right. Oh, I didn't set a response. That's okay. We'll do it here. There's my response. So we ask the question, and then this returns to us like multiple things. It seems kind of overwhelming, but this is the information we want. So we can call response.response. Creative destruction is a process whereby outdated arrangements and markets are destroyed during whatever. All right, so this is essentially what we want. Now, what's kind of interesting about this is this response object. If you look at it, .keys. Okay, not only does it come back with a response, it comes back with source nodes, which I find interesting, because it means that these are the nodes that it retrieved in giving you the right, in actually constructing the answer. So you can see, what's kind of, so you can see it has like that information, right? It has the ID, it has the text, obviously. It has, it's a node. It is that node object. So it has that, let's do dunderdict.keys again. Oh shoot, I wanted to get the node. Node0.node.dunderdict.keys. Okay, so yeah, I think this would be interesting, right? Like the start character index. Why? Because now, like, think about it, like you can highlight, if someone asks a question, not only can you give them the summarized answer, but you can highlight the original document where this information came from, right? So this is from the original document where this node begins, right? So, and from there, you can like search it or whatever. So that's essentially it. Let me cover, I guess, a couple more things. One thing, right? So just to review what we did, we read in the document, right? We use this PyMu PDF, which actually uses this module called fits, to then, read open a PDF, get the text from each page, assign it to just a large string, doctext. Then we created a document. You have to create a list here because this thing, is get nodes from documents. So this has to be a list of document objects. We initialized it with the doc text. All right, so that's good. Then we parsed it into different nodes by declaring a sentence splitter, right? Saying the length, the number of tokens should be around 1024, but don't split on sentences. Then we did the get nodes from documents. That returns to us our chunks. Then we get the embedding from each of the chunks, meaning we get the vector, right, that corresponds to each node, and we store that embedding on there. Now this function does a lot, okay? Let's take a look at it. If you type in index, you can see that this is the index vector store index object. I wonder if I look at dunderdict.keys of this thing. Yeah, so this is kind of, it actually has a good amount here. So this is called an index. And remember what we said was that an index is like kind of the technique, right? For storing our nodes. Meaning we could just store them one by one, like one after the other, and have the embedding, and then we have to search through all of them. We could also think about like getting the keyword of each one and then tagging them with keywords, and when a question comes in, search for just those nodes that relate to the keyword, right? That's the index. But when you pass through nodes to this function, one creates an index, meaning the strategy for storing. Two, the other thing it does is actually creates the vector store itself. Right? So if you don't specify it otherwise, this will create your vector database for you. So you can see that here, I think, right? Like the storage, it's probably this storage context. Oh, there it is, or vector store, right? Index, I wonder if we see that, index.vector store. You see that? And that's returning to us this simple vector store, right? Which is different from a simple vector store index. So one, it creates the index. Two, it creates the simple vector store. Three, it actually will, if we did not get the embedding from each one of these nodes by calling getText embedding and passing through the content, it will do that for us too. So I just show that for you. Here we can comment all this out. We don't need it. And just do this. And run it. The reason why I bring this up is because this vector store index thing, right, it's going to need your OpenAI key. And by default, it's going to be using OpenAI. So look for your OpenAI key, and then from there, it will embed all the nodes, right? Get the corresponding text vector for all the nodes, store that on the node, create the index, create the database, right? And then from there, we can get our query engine. So this will still work. Query engine.query. I didn't put in response. Let's do response equals that, right? And then same thing. If we do response dot source nodes, is that what it's called? Square bracket 0, right? That still returns to us that original node. Okay. So this is all the code, basically, to create a RAG model or a RAG pipeline. From ingesting the data, right? Parsing it, we specified a parser, right, from our document. Then we stored it and created the embeddings and the index. And then from there, we created a query engine, right? And then we can imagine the users submitting the queries. Yeah, Conwell.
So regarding the query itself, so isn't there a possibility that more than one index contains an answer for a question? Like if we get grouping this on the list of chunks, and there are two chunks usually which contain the answer.
Well, it's going to return to you when you submit a query. It's going to it's going to send back multiple chunks to OpenAI or to the LLM and present them. And you can specify how many you want to be returned, like the top wants to be returned. Was that your question? Did that answer it?
So for a particular question, for a question like this, I just saw that the answer was just a plain paragraph, like a sentence or a group of sentences. So if the answer is found in more than one index, one index, will that be sort of combined?
Oh, it will just query right here. It's just querying a single index, but it's returning to you multiple chunks. It's getting back. If you look at the number of source nodes that are getting sent to the LLM, I guess it's only sending back 2 of them, but you can specify to send back more than 2 chunks of data to the LLM.
And then I have another question, and that is regarding this approach working fine on the restaurant reviews level. Like, wouldn't be this approach dependent on the data we have? Like, if we have followers approach of grouping it into chunks, I'm not sure how the indexing will work on the restaurant reviews level.
You would probably just choose each review is a separate chunk, right? The whole CSV file is the document, and then each review is a separate node, right? And then when someone puts in a query, you would get back. It would go through and find the 3 or whatever most relevant nodes and present that to the LLM.
But in that case, isn't the approach which already follow fine? Like, if we are not utilizing the power of chunks.
This is very similar. Like what we did previously is basically this same approach. What's different here is if you have a document, now there are ways to split this up, right? The actual vector store index, I'm guessing, is more efficient than what we have. And then the other thing is, right, here we're using something like in memory. If you want to switch this out for a different database, right, you can use this same kind of thing, take the nodes and now pass through the nodes to a different database. And Llama Index will allow you to now store this in a different database, choose a different indexing strategy, things like that, right? You can see that there's different kind of response modes, like here it's summarizing it, but you could give the response mode as a form of more like a chatbot, things like that. So it's like what we're doing is what we've done originally is the same kind of procedure as what's occurring here, but now we're using a more professional library that will give us more flexibility to swap out different strategies for parsing our data, different strategies for storing our data, but then also can go a lot more fancier, right? It's a library that has pre-written code for doing these commonly used techniques with LLMs, right? With the RAG model. Narapati.
So when we instantiate this vector store index class, this is where we use the OpenAPI
Yes.
API, right? And that means that it doing all the embedding, which is pass the list of nodes, and then it will do all the embedding first.
Correct.
And also, this means that we have to have OpenAI API key in our environment variable.
Yeah, there is probably a way to directly pass it through here as an argument, but you'll have to find that. I just didn't see it in the documentation.
Okay.
Yeah. All right. So this is kind of honestly, if you understand documents and then chunking, right? Chunking the data, splitting it up, and then the fact of kind of what does each node store on it, right? It stores essentially the text, but then it can store some metadata. And then we feed those nodes to a vector database. And when you do this, it also embeds, right, the document, meaning it stores on the nodes and embedding, right? And then from there, we have this vector database. We can create a query engine, meaning a way to actually ask the data, search through the data. Okay, so that's what we do next. And then we finally submit our queries. That will stay consistent throughout Llama, when we're using Llama Index, right? We can switch this up. There are different pieces you can mix and match, right? Like it might be interesting when we get HTML data to parse that separately, right? Then maybe we don't use, the fact that a new paragraph actually has HTML tags, right? The P tags, and we want to chunk things up based on those P tags, right? Or a heading and a P tag goes together, or maybe the heading is metadata, right? Like you can start to see how as these things change, using a library that kind of has thought this through and created these strategies already for you, that's going to be pretty useful. Okay. One other thing it has is like you can just submit like the IDs from like Google Documents, and it will read in the text from those Google Documents for you. Right? Like things like that are like these pre-built tools out of the box specifically for this pattern, right? This RAG pattern. All right, so we'll leave it there. Obviously, I'll post this video